Hello all, welcome to part 13 of the Wireless LAN Security Mega Primer. In this video, we will look at SSL man-in-the-middle attacks and other traffic snooping attacks over wireless. So now is the part where it gets even more exciting. So to understand a little bit more about SSL, MITM and things like that, I've already covered this in two previous videos which I had created way back in 2008. So here are the URLs, number 100 and 101. Links are also posted in the page below. And I would really suggest that if you're not aware about, the basics of SSL and man-in-the-middle attacks using SSL, I urge you to go through those videos. The reason I'm not repeating it is because, practically I'll just be redoing what I had shown in those videos exactly toto. So then what am I going to do in this video? Well, in this video, using the setup we created and the fact that the victim is connected to us, exactly starting off from the place where we stopped in the last video, I'm going to show you how to do an SSL man-in-the-middle attack. So let's go to our setup. Now my phone is still connected to the access point, right? And I just switched it on so it'll kind of reconnect in a moment. Everything else is exactly the same. We have the whole 80.0 interface and all of that. So now comes in the question, how would we do a man-in-the-middle attack? Now, different people do it in different ways. I will actually use DNS spoofing for SSL MITM for at least web-based applications. So what I'm going to do is, I'm going to run a little tool which ships with Backtrack called DNS spoof. And what this is going to do is basically go ahead and sniff on an interface, and whenever it sees a DNS request going on that interface, it will reply with a DNS reply saying that the whatever host was there in the DNS request has the IP address of the attacker machine, right? Now I've described all of this in those two links which I have given. So if this is too fast for you, go back, watch those videos. I've taken this up in detail there. So what we will do is, if you remember from the previous video, we have the following interfaces. MITM is actually the bridge interface through which we are bridging traffic between ETH0 and AT0. Right here, these interfaces are. So what we are going to do now is actually run DNS spoof on the MITM interface. Now if you notice, it actually says, well, sniffing, and here is a little filter expression, UDP destination port 53, which is actually for DNS, and not source 10.02.15, which, if you remember from the previous video, is actually the IP address of the attacker machine. Which means now DNS spoof is monitoring for all DNS traffic apart from that originating from the hacker machine, and it is sniffing basically on the MITM bridge interface. Now this is what will happen when this phone makes any DNS request. DNS spoof will immediately figure it out because it is sniffing the air using the MITM interface, and it will immediately send a DNS response. Now the DNS request has gone through the internet, and whichever is the DNS server configured will also send a reply. However, because DNS spoof responds faster, the iPhone will actually get the DNS response from DNS spoof first and use that for further IP level translations. So let me give you a simple example. I've started my phone and I'm about to use Safari. And what I'm going to do is, if you notice, as soon as the browser started, nothing is here, but actually the phone, which has an IP address of 10.02.17, has made a DNS request for apple.com, and we have replied basically saying that apple.com resides on 10.02.15. Anyway, so now here is the problem. If let's say we type in google.com, then DNS spoof will send a response saying google.com lies on IP address 10.02.15, which is the attacker machine. So the phone will then send a HTTP request to 10.02.15 on port 80. But here is the issue, there is nothing listening on port 80. So the next step is actually to have an MITM web-based proxy to listen to port 80. So let me start that up. The proxy which we will use, which many of you may be familiar with, is Burp Suite. So just take a moment for Burp Suite to actually open. So proxy service has started on port 880. Now we'll have to make some modifications in the options tab. Now the first thing is this. There is no proxy configured here, which means it will just send data to port 80 of the attacker computer once the DNS response from DNS spoof goes through to it. So which actually means we'll have to start two services on port 80 and 443. So let's add port 80 and let's also add port 443. Now there is a little catch here and we'll come to what it is in a second. And if you notice now there is something running here. So now on my phone, let me type in google.com. If you can kind of see this, I've typed in google.com and I'm about to click on go. And if you notice, there was a little error which you got on our screen, right? Which if you carefully look at it, it's a bit increase the font. I don't know if this is viewable. It actually says burp proxy error, invalid client request received. First line of request did not contain an absolute URL. Try enabling invisible proxy. So here is what is happening. Well, Burp Suite by default, if you've done all these web application pen tests, you would remember that you actually set the proxy server and point it to Burp Suite and the port 8080. Now we are doing an MITM attack and hence the client is not in our control, which means the client will just send an HTTP GET directly thinking that 10.02.15 is not the attacker machine and port 80 is not the listening port of the proxy. Instead, it is the actual Google web server. And this is where we need to make a key modification. Click on edit and we actually say support invisible proxying for non-proxy aware clients. By checking this, what happens is even if Burp receives a normal HTTP request, it will actually proxy it in turn. Similarly, let's do the same thing. Let's update this and let's actually do the same thing for port 443, which is where the SSL requests will come through. Right? Awesome. Now let's go to the intercept tab. Intercept is on by default. Let's see what happens now. So I'm on the same page and I'm just going to refresh that page. Right? And if you noticed on our screen, we actually got a intercept was on and we actually have gotten the web request. So let's actually remove intercept and forward everything so that the Google page loads normally on my phone. This is what would happen. If you notice in the background, a lot of DNS requests are going through, but finally Google's page is loading perfectly. But note, it is loading through my proxy. Now, let me do the following. In the first MITM attack, what we will do is, I will enter antivirus here, but we will modify that in Burp Suite to Pond. So let me enter antivirus. I'm not going to press enter simply because the intercept is not on and I still remember that. So before I press enter here, let me enable intercepts and let me click on search. So I have searched for antivirus, and if you remember, we can very easily see here that the query is actually for antivirus. Now, one of the cool things which we can do is, people aware of web security, is we can just change this and actually modify this to something else, right? Let's remove the quote for the time being, exclamation mark. And now you would actually see what happens when we do forward the request, remove intercepts, right? If you notice, now we basically go ahead and get a response for the Google request pond. Awesome. So this is how you can very easily modify data. Now, I know what you're wondering. I'm doing all of this manually. Can this be automated? Absolutely. You could even write a little burp script to do that. You could use ettercap. You could use delegate, which is actually a very powerful proxy server. And I have taken care of delegate in the videos which I had shown previously, which was a video number 100 and 101 on SecurityTube, where I talk about the SSL MITM in detail. So please watch those videos. Okay, now let's move on to the next challenge, which is, let's actually go ahead and enter Gmail. Now, if you note, we are getting an error message the moment I type in Gmail. It actually says cannot verify server identity. Can you see that? Safari cannot verify the identity of google.com. Would you want to continue anyway? Now, this is an indication that SSL MITM is happening because we are using a certificate which is created by burp. So all those details are actually available here. If you notice, server SSL certificate, generate CA signed per host certificates, and this is what is giving this error. Now, statistics suggest that almost 95% users will just hit continue here, and this is what is going to kill them, because the moment you hit continue, we immediately come here to the login page and everything looks absolutely fine. Now what we'll do is, once again, we'll go to the intercept tab, enable intercepts. Note, this is an HTTPS URL, and I'm going to type in a dummy password. Of course, I'm not going to type in my real password. So dummy password would be, let's say, SecurityTube demo. Okay, and the whole idea here is that this dummy password which I've just entered should not even be visible here. But let's look at what happens. The moment I click on sign in, it's trying to sign in and we get this dump here. Now if you closely look at this dump, here is where the password is hiding. Can you see that? Password SecurityTube demo. Awesome. And this is how it is possible to actually get the password. If you're wondering where the email address is, here is the email address, and here is the password. And this, if you notice, even burp tells you is going to HTTPS URL. So we could just forward this for the time being, remove the intercepts, and as expected, this would complain saying either the username or the password is incorrect, right? I hope you can see that. So this is how SSL MITM actually works. And I didn't log in, but if somebody had logged in, well, here is the interesting thing. Everything would have worked as is. And the victim would never have known that something happened. So if you notice, here is also a list of DNS requests made by the phone, which our DNS spoof utility has caught and responded to, right? So coming back, this is exactly how an SSL MITM attack works. Now, if you're still wondering about exactly, well, how did the transparent proxying happen? What was that certificate error? What does that mean? And things like that. As mentioned previously to you, please watch both of these videos. I think each one of them is around 10 minutes long, 10 to 15 minutes probably. And they contain all those details. I will also add them to the mega primer list so that you can find them as well. But watch them if you are still not very sure about what happened. So this was a very interesting hack, and this is how, when a victim is connected maybe to a hotspot and we do an MITM attack, an attacker can actually harvest username and passwords even over SSL. Now the only catch was that the victim clicks an OK on the certificate error. And note that, as I said, statistics suggest 95% people do that. Also, from time to time, security researchers find vulnerabilities in browser software, and with which at times even these errors might not appear. I remember an old IE bug which was exploited, where even if the certificate was wrong, no certificate error prompt would be given to the user. Anyway, that's all for this video. Hope you enjoyed it. This is an advanced attack. I would really urge you to try this out on your own with the burp suit which I just showed, or you can even use Delegate, which can act as a transparent MITM proxy for a lot of protocols like POP, IMAP and whatnot. So to understand about Delegated, watch the two videos which I showed you on the first slide and you should be good to go. That's all. Thank you. Please leave your comments behind. Please let me know if there is anything else you would want me to cover in this mega primer, and I would be happy to do so. Thank you. And things like that. I've already covered this in two previous videos which I had created way back in 2008. So here are the URLs, number 100 and 101. Links are also posted in the page below. And I would really suggest that if you are not aware about, the basics of SSL and man-in-the-middle attacks using SSL, I urge you to go through those videos. The reason I'm not repeating it is because, practically I'll just be redoing what I had shown in those videos exactly toto. So then what am I going to do in this video? Well, in this video, using the setup we created and the fact that the victim is connected to us, exactly starting off from the place where we stopped in the last video, I'm going to show you how to do an SSL man-in-the-middle. Hello all, welcome to part 13 of the wireless LAN security mega primer. In this video, we will look at SSL man-in-the-middle attacks and other traffic snooping attacks over wireless. So now is the part where it gets even more exciting. So to understand a little bit more about SSL, MITM, so now comes in the question, how would we do a man-in-the-middle attack? Now different people do it in different ways. I will actually use DNS spoofing for SSL MITM for at least web-based applications. So what I'm going to do is, I'm going to run a little tool which ships with Backtrack called DNS spoof attack. So let's go to our setup. Now my phone is still connected to the access point, right? And I just switched it on so it will kind of reconnect in a moment. Everything else is exactly the same. We have the whole 80 interface and all of that.